welcome. Great to be here. We've been doing a tour of Oracle Code events across Europe, and this presentation is kind of near and dear to my heart. We've been talking a lot about culture, DevOps, cloud-native technology, cloud computing, private, hybrid, multi-cloud technologies ever since KubeCon in Seattle back in December. We launched a range of new technologies around the whole cloud-native stack that can run on-prem Linux, but also can run up in the cloud, Oracle Cloud Infrastructure. So we're talking a lot about that today, about kind of the history of how we got to where we are today, and why don't we just jump on into it. So the sort of three different areas we're talking about are culture, code, and cloud, 3 C's. And really it's about how we've evolved all three of these things together to bring us to where we are today, which is almost, I'd say, a golden age of developers. We'll talk a little about DevOps and DevOps culture, the benefits of DevOps, and how companies are finding benefits with DevOps and DevOps approaches. We'll also dig into what's happening with open source, cloud-native computing, a lot of the CNCF, the Cloud-Native Computing Foundation technologies. And that's kind of how I came to Oracle. Been with Oracle about 3.5 years. I was co-founder and CEO of Stack Engine, which was a container management, Docker management startup in Austin. We're still based in Austin. And we kind of got our start in a facility like this called Capital Factory in Austin. So this is like a very familiar place, good innovation buzz. And we're a bunch of developers that really had focused on automation, infrastructure management, and kind of what was happening in software development around containers. It was Docker then. It wasn't Kubernetes back then, but that has emerged a lot in the last probably 2 to 3 years. We'll dig into that some more too. So around culture, DevOps itself has been around probably 5 to 6 to 7 years, let's say, maybe longer, depending how you look at it. It's part and parcel to how startups and smaller companies have been using and innovating and building out new technologies. And there's many variations on DevOps these days. We're hearing about site reliability engineering, a Google term, SRE. We're hearing a lot about DevSecOps, where you shift left and bring security into your development. AI ops, no ops, but in the end, they're all trying to accomplish a similar set of technology advantages and cultural and process advantages for lifecycle. Code itself has gone through also a whole range of new developments. Open source technology has almost democratized how cloud companies can now take their technology and push them into the broader community. And we're seeing everyone from citizen developers, folks who are using it at home on the weekend can use the same technology that Netflix and Google and Facebook and the larger cloud scale companies are using. So it's something that has democratized how you can develop small companies, big companies, and is happening across the board. And then cloud itself, it's unlimited scale, power, and compute that can run anywhere. And we'll talk about how culture and code also then drive choice, so you don't have to just choose a single cloud strategy. The ultimate end of all this era here in this epoch is multi-cloud, choice for the customer, choice for the enterprise, so you can run anywhere you want to, on-prem, in-cloud, hyper-cloud, multi-cloud. It's kind of up to you, and that's where DevOps and open source code can drive you to. So, well, if you think about kind of how we got here, there's kind of 3 epochs that are represented in this slide, and they kind of capture 3 major application development phases that have happened probably over the last 30 years. I've actually probably lived through most of these myself in all these transitions. And each transition has some difficulties and some challenges. The second half of the presentation, we'll talk about those challenges. And if you take a look, there's 4 kind of major components that make up each of these epochs. There's how you develop, the development process. There's the architecture. There's how you deploy, and then where you deploy. If you think of the early phases back 30 years ago, we had a waterfall approach. We'd throw everything over the wall and go to the next wall and kind of work our way down the waterfall. And that developed monolithic applications that were deployed onto physical servers and then into a data center. So each 4 of these kind of represented the four components that made up that initial epoch around cloud computing and, not cloud computing, but application development. And then we saw some major transitions happen, probably about 10 to 15 years ago. Went to a little more agile approach. We went from monolithic to more client-server, to N-tier, more distributed computing models, which brought their own challenges. Virtualization, went from physical to virtual servers. You think of VMware and the challenges that brought in, and the opportunities to change the data center architecture into a hosted environment. Now we are today moving into areas we'll be talking about in this presentation. So the DevOps application lifecycle, DevOps working together, CI/CD, continuous integration, continuous delivery, resulting in a microservice architecture that can be deployed on containers and then run in the cloud, private cloud, multi-cloud, hybrid cloud, any cloud you want. So together, these kind of mark and create something that works on each other. They amplify one another to create this whole new era of application development. But each of the challenges that come from this, as you move to a DevOps transition, a lot of folks are having challenges to get to a DevOps culture. It's not simple to do. We'll talk about some of those challenges. How do you now refactor or build new applications in a microservice architecture, managing just a few servers that were virtualized, hundreds, thousands, potentially millions of microservices running in containers across the cloud. New management challenges, new automation challenges. So it's a slide I like to kind of give a little background in terms of where we are, where we've been, and kind of where we're going. So I myself got here. I have a line through my logos there, but I've done a lot of startups in my career, about 10 startups, 20 years in Silicon Valley, the last 7 in Austin, and worked in several large software companies, including Oracle, where Stack Engine was acquired 3+ years ago. But my career kind of spans those eras and those epochs. Think about S&P management, managing the network infrastructure, moving into more of an application discovery and a virtualization phase. So my company Nlayers was acquired by EMC, which then spun us off to VMware, so spent a lot of time working on VMware and virtualization management technology at the server level. And then went and virtualized the application, started working at the container level. So the challenges along the way kind of are consistent. So that kind of hopefully gives you a little background on where I came from. Like I said, based in Austin. I came out of the software development area myself, and I've spent a lot of times in hands-on in the startup era. And like I said, this building reminds me a lot of where we got started ourselves. So let's talk a little bit about DevOps, cats and dogs working together. And it's really not mass hysteria. Really, it's about coming together and working together as one. But getting through that process can be a challenge. And so culture and DevOps, the first thing we'll talk about. There's a lot of really technical, very business-oriented benefits that have come out of DevOps. And if you've all ever had a chance to read the State of DevOps report, and they put out every year, it's a very statistical survey, thousands of practitioners are surveyed. And really what the folks who are doing, the scientists who are doing here, are trying to understand what are the practices, the best practices, the patterns that high-achieving IT groups who are using DevOps, how are they being successful versus folks who are in different groups. So you see that from a deployment frequency standpoint, 200 times more deployments, faster recovery from failures, a lower failure rate, faster release times. All these things are statistically identified as benefits you get from adopting a DevOps culture. If you look at the groups they put together here, we have low IT performers, medium, and high IT performers. Deployment frequency goes from months to weeks to the high IT performers deploying multiple times a day. Lead time for changes. Once you commit a change in code, how long does it take to get running? 1 month to 6 months, 1 week, less than an hour. Pretty compelling. Mean time to recover. If you have a failure, how fast can you recover from that failure? The whole chaos monkey and the chaos model is that you should always be able to recover very quickly because you design that into your architecture. Day, hours, less than an hour. Likewise, change failure rate. How often when you make a change, do you have a failure? A lot less often. An interesting stat here is if you take a look at the details, this goes, it gets worse as they start adopting DevOps culture. When you think about it, that kind of makes sense. A lot of times you go through a lot of pain and you have to challenge your way through that and push your way through that to get to the benefits. So there is some issue people see as they work their way through DevOps. Sometimes things get worse before they get better, but there is a light on the end of the horizon there. So that's business and technical benefits of building out DevOps culture. Pretty compelling. But there's a whole range of people benefits, which I think is also, has come out over the last couple of years, that people who are in groups that are using DevOps cultures and DevOps methodologies have happier employees. They spend less time doing the work they don't like to do, the mundane work, the fixing of the bugs. They get to do new innovation work, and they're more than 2 times likely to recommend their place of work than other folks who are not using those models. So they're happier employees. I've also seen surveys around open source. Open source users tend to have a broader community. That's not only inside their company, but it's outside their company. Meetups, you have a broader group of constituents and community that you can tap into. And open source technology opens up job opportunities. It's easier to recruit people in. It's also easier to retain people. So business benefits, technical benefits, people benefits, all very, very positive aspects and actually statistically supported by surveys and analysis. So one of the best practices or patterns they always use, and they've identified, is automation. Makes sense, right? What types of automation? Configuration management, testing, deployments. Once again, you look at the difference in the different groups. Low IT to medium to high IT performers, you see a much more significant adoption of automation technologies. From test deployment to CI/CD to version control. So automation being another key practice and pattern. And the last kind of sort of process I'll walk you through in analysis is they did a structured equation model, an SEM model, trying to look at the conditions for success. So if the outcomes are better IT performance and less deployment pain, how do you work backwards to find the leading indicators or the patterns that create the path to get to these? So to work backwards, they said, well, the first things that people start doing is lean product management. And that makes sense. You got a development team using DevOps. Well, if the product management team is not supporting that, the rest of the company isn't keeping pace and changing how they work, I think that's important. So it's not just developers that are on hook here, it's the product management team also. Product management team, important to actually keep up, work in small batches, take advantage of this fast life cycle versus actually putting out requirement documents, waiting for them to be done, spending another 6 to 9 months to do another requirements document. And that's kind of the way it was about 15 years ago. So, a bunch of test best practices. We talked about automation in the last slide, CI/CD, shifting left on security. Big discussion now around DevSecOps, bringing security earlier in the process, and empowered teams, which leads to kind of discussion around transformational leadership. We talked about development teams need to change, product management teams need to change, but the leaders that are managing this, the directors, the C-level management, has to have a commitment to DevOps. Recognize it, support it, inspire it, and have a vision. Because there will be some issues as you work through that. There'll be challenges, make it worse before it gets better, like we saw, right? And so a lot of the information is on these State of DevOps reports. They come out annually. Each year they get more and more detail on best practices, patterns, and things you can adopt. So, highly recommended. So I have a little Mr. Robot, kind of democratized open source technology here. Maybe that's the far extreme of where you could take open source and hacking. But the idea is that a lot of the work that's being done now around cloud computing, CNCF technology, open source technology, full container revolution is really driven from this open source model. When we started Stack Engine, it was early days of Docker. A lot of the Docker founders came out of France, and a lot of our early customers at Stack Engine were from France and from Europe. So feel somewhat at home here. The early days of Docker were really about trying to get the developers enabled. So how do you get them working on a laptop? Millions and millions of downloads, millions and millions of pull requests. Docker did an amazing job to get container management and containers taking off. Really, it was the early simple stuff, dev, test, ops, simple orchestration. But as they move to the next phase, once you start developing, what happens next? You got to start managing it. Production questions, orchestrations, cluster management, how you deal with all those issues. And that's kind of where we are today. We're in this second phase here, in container adoption and rollout in this cloud native journey. Kubernetes has taken over from Docker. We went to the first DockerCon in 2014. There's about 500 people, a bunch of small rooms like this. Now you can expect KubeCon in Barcelona coming up to be over, they say, 12 to 14,000 people. So it's expanded dramatically, and Kubernetes has kind of taken over this next wave, where Docker now is an assumed part of the plumbing and the technology, done a great service to the industry, but really the next phase is around orchestration and trying to bring things together at a production level. How do I manage it, run it, keep it running at a high availability level? Very important. The next phase then brings all those things together. So we have much more focus around end-to-end operations, around managed services. The early days of Kubernetes and the early days of Docker, it's all do it yourself. Everyone has to manage it, run it, stand it up. Not necessary anymore. Managed services, managed Kubernetes services are offered by all the cloud providers. Our team in Austin built the managed service, the Oracle Kubernetes Engine, OKE. Great technology, certified, compliant with CNCF, but you have a choice, and that Kubernetes can run anywhere now. It's supported across a whole range of different platforms. So end-to-end, we're talking about real business operations, intelligent operations, and that's kind of where we see the next generation going. So, open source, you'll be hearing about the FN project and functions coming up. Great presentation. We did a lot of work in the community. We're platinum members of CNCF, supporting Kubernetes. We've been obviously one of the proprietors of Java, OpenJDK, all the openness that's come out of Java, especially the last couple of years, and are continuing to commit to a whole range of technology sets that are open source based. They're being offered out to the community. So, future is open. Many people don't expect Oracle to be saying that, but if you look at the history of Oracle, MySQL and Java, even Linux, and where we're going now in terms of the technology sets we're using in terms of Oracle Cloud Infrastructure, this is an open-driven architecture. This is kind of a snapshot, I guess 3 years ago now, 2016, of where container management was just 3 years ago. Doing well, getting strong adoption, but most of the adoption, if you notice, is in the development CI/CD DevOps area. Kind of stuff that we would use ourselves as developers. Okay, a little less so in terms of refactoring your apps, building new apps and microservice applications, etc. So you're not seeing as much 3 years ago in terms of stuff you would use to build and deploy applications, but mostly just early development and adoption internally inside IT, in terms internally inside that development itself. But now, this is the most recent cloud native computing survey. Still high uses of development and test, POC, proof of concept work, but look at the growth over the last few years in terms of reduction. Huge levels of reduction usage of containers and container technology across a whole mix of public cloud, private cloud, and on-premise. So once again, you're seeing now we're moving out of that early development phase into a much more production-oriented phase, right? Might be a little bit of an eye chart here, but the real point is that not only are we seeing Kubernetes going up, so the darker purple lines are more adoption, the smaller purple lines are less adoption. These are the different projects that CNCF supports. And not only Kubernetes is strong, but things that support monitoring Kubernetes, like Prometheus, things around logging and tracing, FluentD, Zipkin, around networking and storage, around package management, like Helm. These are also now getting strong adoption. You start seeing more stuff being adopted outside of just containers and outside of just Kubernetes itself. So it's the ecosystem and the stack that's now developing, that's being used now by many more people in terms of production level usage. So we talked about culture. We got first C in. We talked about code, second C. Now we're going to talk about cloud. You have the power. Hopefully Keyman, Shiwa, or folks you might remember. So it's kind of exciting. It's just, even over the last few years, what cloud infrastructure has brought in terms of increasing performance and creating better latency, better IOPS, HA by design. Super excited to think of, now you have this bare metal cloud. You can run VMs on it if you want, and you can run open source technology on top of that. It's a huge win-win in terms of developer and developer access. So the power we're seeing is spread across a variety of different shapes. Okay, easy shapes to use for web applications, smaller VMs, for example, all the way to stuff you might use with AI, ML, Spark, big data applications. We do a lot of work with the startup community. We have a startup accelerator in Austin that do a lot of work across the Oracle Startup Accelerator program. And you see folks maybe starting off on the VM side, but there's some really cool AI apps, ML, big data apps in the healthcare area, financial services area, that are being used to do some incredibly cool rendering analysis that you never thought would be possible. And that's all available through these different types of shapes that allow you to build and scale and elastically adopt the technology. So IaaS is cool. You got all your compute. We also have a variety of storage to choose from, a variety of networking to choose from. So you could really Lego this stuff together any way you want to. Big Lego box, small Lego blocks, connecting to a variety of different types of services, all giving a developer a rich access to stuff that wasn't available 5 to 10 years ago, instantly out of the box. All right. Do any Game of Thrones fans out there? Okay, yes. So, new episodes are coming out, final season. We talked about culture, code, and cloud, all the good stuff. But there's challenges ahead, and I think we've kind of reached a certain kind of plateau with cloud native. The first phase may be completed. You see a lot of unicorn deployments. People are experimenting around, but to get more technologies on board and more enterprises, more development teams, we have work to do. And that's a lot of the work that we've been focusing on in our development team. So what are those challenges? There's 3 key challenges that came out in a recent survey from Cloud Native Computing Foundation. So we have all that great stuff in terms of adoption. What are the key challenges? First one, cultural change. Cultural change for developers. How do you help developers move out of their current approaches into a broader, more DevOps-oriented methodology? Complexity, lack of training. You're seeing a lot of the work that was, the fear around security and networking and storage, that's kind of worked its way out. There's still issues there, but people are working through those issues and really focused on them. Now we have a lot of people issues, culture issues, training issues, complexity issues. And we'll kind of walk through some answers to those questions as we go through this. So, why do we see these different sets of issues? Well, cultural change is hard. I've done a lot of presentations since I've joined Oracle, and I'll talk to CIOs and directors, et cetera. And a lot of times they'll stop me during my DevOps slides and ask about culture and how they move teams forward and how they broaden the DevOps methodologies. It's a concern at the top level of organizations, even more so than sometimes the technology itself. So, because culture change is hard. Complexity, comes with all this choice. You have a choice of all these open source platforms that are out there, and you look at the CNCF and the Cloud Native Computing ecosystem chart, the landscape chart. It's an eye chart. So it's hard to walk through. It's hard to understand. You have hundreds of different software packages to use. So how do you choose? And then so many people who have had cultural change issues or complexity issues have chosen I'll just choose a single cloud provider and let them choose that for me. Well, the whole point of choosing open source and doing DevOps is to have choice. Be able to run anywhere. So the logical conclusion that we think is that there will be a multi-cloud world out there. You should be able to choose any cloud you want based upon compliance, regulatory, use case, technology, especially as the platforms become more and more similar in terms of the computing technology they're using. We'll see kind of a homogenization of the cloud technology, and then you can start choosing based upon what works best for your application, be it technical, be it business, be it cost, be it compliance or regulatory. I'll walk through each of these a little bit. We're talking about culture and cultural change issues. And we kind of think on the first set of problems around cultural change for developers, the first challenge is to think inclusive and focusing on that and. So it's not just new technologies or cloud native or modern, but it's also traditional technologies. So cloud and on-prem, modern and traditional. One of the things we've worked on hard is to try and look at our Java customers and our WebLogic customers and our database customers and find ways to connect those into this cloud native world in easy ways that kind of are in context to what they do. And I'll walk through a few examples. I think there's a session coming up on this right after mine, but really one thing to focus on first is WebLogic. How you help a WebLogic customer move over to the cloud native world and by using the WebLogic, by using the Kubernetes operator pattern. The standard pattern now used by many Kubernetes providers, and it helps you run WebLogic in the context of a Kubernetes cluster management technology set. We have some really great use cases that are up on our cloud. CERN from Switzerland, Verizon, a variety of other folks who have some really key big applications are moving over from WebLogic, but they're using the WebLogic operator for Kubernetes as a way to run WebLogic apps on top of the Kubernetes environment. So you don't have to refactor everything, you're not taking everything apart. It's a good way to get started. And then over time, you can start then moving and improving all that work. There's a huge set of information available on the GitHub pages. Take a look, good examples, and some good success stories too. So. Helidon is something we released probably about 6 to 9 months ago. It's in a set of technologies that are trying to help Java applications run better in a microservice framework. So we have a lot of Java customers, and I've been speaking to a lot actually on this tour too through Europe. And they're all looking for different technologies and ways to bring serverless in, bring microservices in, and leverage a lot of the new cloud native technologies. My group, which is a cloud native team, cloudnative.oracle.com, we built a lot of solutions and use cases that leverage a lot of these technologies too. But these are core tools for helping anyone who runs Java, is writing new microservice apps, to take advantage of things like Kubernetes and Docker containers. So we'll have a couple sessions this afternoon to kind of talk more about some of these, in particular around serverless and Java. One of the more exciting things, and today's Thursday, there's a new release coming out. We're open sourcing a Kubernetes service broker. I think it's coming out tomorrow. That's right. And it's a broker that allows things like the autonomous database and other applications to now use Kubernetes and it provides sort of an API gateway in a way. So the service broker, we've built integrations for the autonomous database, the autonomous warehouse. We're talking about that next. And it allows you to connect new applications, modern applications that you're developing in the cloud native context with an autonomous database. So you have all the automation now in Kubernetes and containers. And then you have the automation on the database side, creating a whole new pattern for building out new modern applications based on new automated, self-driving, self-healing technology. That's supposed to be announced tomorrow, so keep an eye on the website. They'll be open sourced, I think, on Thursday. I talked about the and running hybrid as an on-prem and cloud opportunity. We've done a lot of work on the cloud side with the Linux team to create kind of an end-to-end hybrid cloud framework. There's lots of really key kind of fun use cases people are working on that are active in the market today and active on our cloud. We have folks who are developing in the cloud and then deploying on-prem. So these are quick, disposable, test environments, dev environments. You spin them up, you spin them down. Perfect application, first application for cloud usage. Then you keep deploying on-premise, but you have cheaper deployment options now out in the cloud. application portability, maybe I want to run certain parts of my app or certain apps in the cloud or on-prem. Kind of depends where you want to go. That's another use case in fact that we're seeing in the model. And the third sort of biggest one in these top three are DR and disaster recovery, where I might have my on-premise solution running, and I want to be able to run my DR site up in the cloud and have that available in case anything goes down, or vice versa too. And that's that workload, specific distribution, intelligent orchestration, federation. These are more sophisticated use cases that we're starting to see where people are running multi-cloud, more automated intelligent orchestration. That's a little further out. The technology's there. A lot of papers being presented on that. And we're seeing people experimenting with that today in an automated way. These first three are really solid hybrid cloud use cases versus a lot of customers now support. So, thinking inclusive to get over the cultural change issues. We also have to choose sustainable technologies in ways that help us get through complexity. And I think of the early days of Stack Engine and containers, everyone had to do it themselves. We saw a lot of folks who stood up Kubernetes themselves. They were, got the Kubernetes trophy. They put it on the mantle. Very, very proud of that. What they found over the last year or two is that it takes a lot of effort, time, and expertise to run Kubernetes yourself. And you become a Kubernetes expert versus being a business expert or an application expert of the things that are running on top of it. So what you start seeing is that you want to have managed services that do that for you. And a managed service really helps you have a more sustainable approach. You don't have to learn all this stuff. We'll curate that for you, we'll build the stack for you, we run all the sophisticated backend masters, etcd servers, all the networking, all the storage is all set up. High availability is set up for you. So you don't have to actually navigate your way and learn all this, work your way up that learning curve. You can kind of leapfrog all that technology and go directly into a managed service. And that's one of the benefits that it's going to help people really get through and power through these technology issues. Because before, you basically had to do all this stuff yourself. You could still run the application. You had to do high availability, platform backup recovery, Kubernetes releases come out every 3 months. You have to keep up with those, patching, etc. In a managed service, all you really are focusing on is the stuff you care about, your application. The cloud provider does all these things for you. Okay? And I think a great example is the Oracle Container Engine, OKE, where we're actually running that for you. We manage the control plane, manage the masters, the etcd servers, all that stuff is managed for you and allows you to focus on the application. You don't have to keep that up and running yourself. We keep up with the releases, automatically put in the patches. If there's a bug, a security issue, we fix those, and are staying up to date to all that stuff so you don't have to. So managed services is one of those hacks right now that helps you kind of power through all the complexity and get through the fear of having to learn all that stuff yourself. Right? Along with the Kubernetes capabilities, a whole stack of new technologies that are coming out. We just released a resource manager, which is a Terraform as a service technology. It's a cloud service that uses Terraform for automation, so even more automation now. Automation on top of automation. We have a registry, Docker V2 compliant registry. We can store your container images. Functions has been released in limited availability, and it's based upon the FN open source project for serverless. Streaming, container pipeline for CI/CD, and observability and analysis. We have a telemetry service that helps you do monitoring. We built a bunch of use cases around using the telemetry service with Grafana, with Prometheus, and other tools that are for visibility. And you can look for those online too. Notification for hooking into things like PagerDuty, events using the Cloud Event Standard, which is a CNCF standard of how different technologies event together. So we thought about it being inclusive. We talked about being sustainable, and the final step is really being open and adopting these open technologies, because open source enables choice. And it gives you the power to do what you want to do. Closed proprietary solutions will lock you in, and the cloud lock-in really starts making you an expert and proprietary APIs, proprietary technologies. So all this work is going on, and all the commitment in the open source, the cloud native world, the DevOps world, is driving to an inevitable conclusion that there's going to be choice available to you. As you adopt these patterns, these models, you should be able to deploy anywhere you want to. So having a single cloud strategy really limits your choice and limits the cost, advantages, and technical advantages of running a multi-cloud or hybrid cloud environment. And as we saw, it's not just new technologies, greenfield, this is also traditional. You can bring in Java applications, you can bring in database applications, you can bring WebLogic applications into this world. You're seeing a lot of that happen now as the tent gets larger of things that can support a cloud native model. Okay? The other cool thing is that they actually allow you to integrate better, and as we've started doing integrations with various partners out there, everything kind of fits together in a Lego kind of world. So all these integrations are very simple, and they're designed to integrate together because it's a stack that has been built kind of specifically on one another. So all these new technologies that come out, if you want to experiment with them, they plug in pretty easily into that environment, especially if you're using containers and microservices and Kubernetes as a foundation. So the kind of wraps up kind of walking through some of the challenges and how to go after and kind of address the challenges that are out there. Places I would go to provide, I'd look to provide some more information and to learn and focus on training. CNCF has a load of training. They understand the issues around the changes that are happening, the complexity. They built trail maps to help you through and kind of provide the garden path to get through cloud native. There's a lot of Kubernetes learning that LinkedIn has a learning section, and some of our evangelists have actually added a bunch of tutorials there. Meetups have been, in Austin, Texas, we start the Docker meetup, and we start the Kubernetes meetup, and there's cloud meetups, and that's really where a lot of people are learning at the local level. A lot of folks come in that maybe don't have a background and they're beginners, but they can actually access a community that's designed to help them learn and nurture and grow. So the local meetup community has been huge, and that's really what the open source community means. It's a broader community that helps you learn and adopt these technologies. So, and there's many developer relation teams that are out there. There's Oracle, there's many more, and they all have evangelists coming through and doing talks and hackathons and meetups, etc. So, one last thing. There's on the cloud native site over here, we built a bunch of solutions too. If you want to take a look, cloudnative.oracle.com/learn, and these are integrations that we built on top of OCI. They use Kubernetes, Grafana, Istio, Kubeflow, Helm, etc. And they kind of show you how-tos, tutorials, etc. So we've done some of the work for you, code snippets, hooks into some GitHub sites, etc. So highly recommended, and they're built for you, so take advantage of those. So, and that kind of wraps up the presentation. We talked about the 3 C's here. I talked about culture, code, and cloud, the opportunities they offer, but also the challenges, how to be more inclusive, sustainable, and open that can drive through those challenges. And I look forward to talking to you guys later today, and enjoy the day. Some great sessions, and I believe the rest are in French, so thanks for bearing with me. Thanks.
Thank you.